Hi, my name is Levi, and this is and I'm in Group 1 of the Bio288 Lab Group 6. This podcast is to discuss the effects on natural and non-natural water-resistant sunscreens on Artemia in a high salinity environment. The purpose of our experiment is to see if sunscreens are having an adverse effect on aquatic organisms like Artemia. Non-natural and natural sunscreens differ extensively in efficacy and composition, meaning that they could have different effects on Artemia, which is why we decided to use one of each type for our experiment. The main ingredient of sunscreens, benzophene 3, has been shown to have negative effects on the health of aquatic organisms, as well as the other water quality when it oxidizes in water. On top of this, sunscreens in general have been known to cause a severe decrease in the mobility of Artemia in their natural aquatic environments. And if the Artemia species are dropping off or are getting driven to extinction by poisons such as sunscreen, this could cause disastrous effects on the food web in general, which is why our experiment is, which is the purpose of our experiment. Our hypothesis for the experiment was that with higher mortality would increase with non-natural sunscreens if sunscreens did have an effect on Artemia, and they would be slightly higher in natural sunscreens, but should be around the same for the controls. This would likely be due to the components of the sunscreen that are listed on the slide below. When doing this experiment, we had to keep some things controlled in mind. This being the ideal environment for the Artemia species. The ideal temperature is between 21 and 28 degrees Celsius, while the ideal salt concentration for Artemia is around 110 grams per liter. Artemia are a species that live in hyposaline lakes, so keeping the temperature and salt concentration appropriate is something that should be kept in mind and could lead to the survival of the organism or death prematurely. Based on those above, Artemia have a high degree of fitness, allowing them to withstand extreme changes in conditions. This makes them a good species to study and gives us insight into how Artemia should be able to withstand some of the effects of sunscreen in their environment. With our experiment, we didn't want, there's obviously a high variability of change, so we didn't want our Artemia to die prematurely due to, or our species, our model species to die just with a small degree of change. So a high degree of fitness in environments is something that we wanted to have. Artemia also have a lifespan of up to 6 months, meaning that a 1-week experiment should be sufficient and that our Artemia shouldn't die by the end of the week. For our setup of the experiment, we had a total of 9 replicates, 3 for our control, which didn't have any sunscreen included in it at all. For this, if Artemia were dying in solution by things such as their food decomposing or something like that, we'd be able to tell, and it would show that our experiment was invalid. We had 3 with our natural sunscreen to see if there was a difference between natural and non-natural sunscreen. The lighter 3 were the non-natural sunscreen. Our experiment was set up as so. We had 9 250 milliliter beakers to make sure that the Artemia had enough space. We covered them with tin foil, filled them each with 21.25 grams of salt, and put approximately 10 species in each of the beakers. They were stored at room temperature and covered with tin foil. As Artemia are a benthic organism, we wanted them to kind of feel like they were in their natural environment and mimic it as close as possible. One problem with our experiment that we didn't notice until the very end, and why our experiment was very unsuccessful, is water-resistant sunscreen does not like to dissolve in solution. And Artemia are a very small 1 millimeter species, meaning that a 250 milliliter space, it's going to be very difficult to see something that small and that looks very kind of clear, like this picture right here. So when we were collecting results by the end of the first week, it was very hard to see organisms, especially in our non-natural sunscreen replicates, as part of the sunscreen did dissolve in solution, causing it to turn a murky yellow, and none of the Artemia were able to be seen. In our natural sunscreen, we had a similar thing where we had mickles forming of white sunscreen. However, we were able to collect data on our Artemia in them. Although in none of our water beakers were we able to see all the Artemia species that we put in the beginning. Based on this, our results for our mean percent survival of our natural sunscreen, we saw around 40% survival, and for our control, we saw around 33% survival. These results are not statistically significant. As you can see, the standard deviation error bars have a severe degree of overlap, showing very low validity for the experiment. On top of this, the p-value, which is set to be 95% confidence at 0.05, is far lower than our critical value, which is at 0.491. Based on our results, we cannot conclude that there was a significant impact on Artemia. One thing that we would like to change for the future in our experiment and future direction in general is to test further into the natural sunscreen. Earlier I said that we didn't want to risk poisoning the Artemia with food by putting them in test tubes. So for the future experiment, I suggest that we do a one-day experiment or monitor the experiment every day in a test tube-like environment with a small amount of sunscreen to see if it will have an effect. This will allow us to be able to easily see the Artemia, but as well, it will allow us to collect data over a period of time, ensuring that not all the Artemia are dying at one point in time. Thank you for your time, and here are my references for the experiment.